Today, we're going to build a simple network composed of two agents. A developer agent will take input from the user and create a simple app. The code reviewer agent will take the code generated by developer, assign a code review quality score along with comments, and send it back for refinement. The developer then will take the comments, refine the code, and send it back for further review. This process will repeat itself a couple of times until the quality threshold is met. Before we start the tutorial, let's see what we're going to be building. Create a React component to calculate the mass of the Earth. This time, we ask the graph to run 5 times. So this is iteration 1, and let's see what our agent came up with. Import React, use state. So there's some constants, and there is the calculation of the Earth. And the reviewer started here with an initial score of 400, so quite low. Has several issues that affect quality score. The component's functionality is misleading, and so on and so forth. So really good code review comments here. Then the developer is rewriting this based on the comments, and boom, the quality score improved to 850, but there's still more comments to come. Now the developer is rewriting it one more time. And now the quality score is still 850. Back to developer is trying to improve. And now with this change, the quality score went to 950. And it says the final version of the Earth display component is excellent in terms of code quality structure. The code is clean, well organized. And finally, our graph ends with our summary node. So total of 5 iterations improve the quality score to 950. Let's navigate to Visual Studio Code and create a new file. I'm going to call this graph.py, but you can name it whatever you'd like. And in this file, let's start with our import statements first. We're going to start by importing load.env, and from typing, we're going to import typedect. We're going to use typedect with our state graph later on. From LangGraph graph, we're going to use state graph start and end nodes. We're also going to use add messages so that our agents can add messages. From typing, we're going to use annotated in our state graph. For our model today, we're going to stick with Azure Chat OpenAI. You can implement this with any LLM that you like, including OpenAI or local Ollama models. The only condition here is the model must support agent calls. Finally, from LangChain core messages, we're going to import AI message, human message, and system message. Next, let's call our loadenv function so that we load our environment variables. Now, for this, I've prepared an environment example where I am including the Azure OpenAI endpoint API key version and deployment names, as well as the LangChain tracing endpoint, as well as the LangChain API key. These are optional, and in your case, you may need to provide your OpenAI keys, and if you're using a different LLM, you may want to provide their respective keys. Back to our file, here we load our environment variables, and now let's define a constant that will hold the maximum tokens for our LLM. Here we're going to define that we're going to use max tokens as 500. Next, let's define our state. And in this case, we're going to use typedect, passing it to the graph state, and our messages list will be just from annotated and basic messages. Next, we're going to create the graph, and the graph will be just as before, state graph and passing the state to the state graph object. Now let's define our LLM, and for this, we're going to use the Azure Chat OpenAI by passing various environment variables from our environment file. Once our LLM is defined, now let's define our agents. For today's example, we're going to have a graph with 4 agents. We're going to start with an initialization state, which will basically just print init and the state and just return the messages. In this case, the initialization state doesn't do much, but it's a good practice to start your graph with an init state so that you know what your state is, or you can set initialization parameters for the very first agent. Next, let's define our developer agent. For our developer node, it's going to be very simple in the beginning. It will be a system prompt where an agent will be tasked to write software code based on user instructions. We're going to separate the messages into 3 arrays: human messages, AI messages, and system messages. And we're going to pass them separately to our agent so that we have a clear separation of our system messages. We've used this technique in other videos. If you'd like to watch previous videos, especially on structured output, you'll see that separating human, AI, and system messages produces better results overall. Okay, so we have the messages ready. Now let's invoke our LLM and we'll print the code generated. At the same time, we're going to return the generated code as a message to the graph. So that's our developer agent, very simple code generation agent. Next, let's add a summary agent. The job of the summary agent will be just to summarize what's been done in the graph and print the end state. Now that we've defined 3 agents, let's add them to the graph. We're going to do that by builder.addNode and then passing the name of the agent. In this case, we'll have initialization, developer, and summary. A very simple graph. Next, let's define our edges. And for this, we're going to define our entry point as the init. From init, it will go to developer, from developer to summary, and from summary to end. Before we can run the graph, we have to compile it. And to do that, we just use builder.compile method. We're not passing any memories or configs. We're just going to do a simple builder.compile. Now, we're going to draw a picture of the graph, and we're going to use a mermaid format to output the visualization of the graph. Once that's done, we're ready to run the graph. We're going to create a main loop function here, and then we're going to call the main loop function later on. While the user input is anything but quit, exit, or queue, the loop will continue, and the graph will invoke with messages and the human message from the user input. So that's as simple as it gets. Let's get a quick overview one more time. We're starting with 3 agents, starting with the init, then the developer, then the summary agent. Then there's a sequential execution of the graph, and this should just generate a code based on the user input. I'm going to save the file, open the integrated terminal, and run our first graph. Okay, so now the prompt is awaiting input from user. So let's just give it a simple input. The prompt is write a simple hello world app in JavaScript. As we can see, the init agent kicked in and reset our state. And now the developer agent is starting with developer start. And then the developer agent has ended and the summary state is printing our messages. And this is the code generated. So let's take a look at the code. Basically, here is the content of the message. Certainly, below is a simple example of hello world application in JavaScript, which is Portuguese translated to Hola Mundo. This example will display Hola Mundo in a web browser HTML, and this generated an entire HTML page. Not so bad. The summary agent printed code, and as you can see, the developer produced the entire HTML page. All in all, good execution. Now what we'd like to do is let's add a code review agent. To do this, we're going to add a code review agent which will execute right after the developer agent and print code review feedback for the developer agent. To do that, we're going to define reviewer agent right after developer and add it to our graph and add an age for it. So let's just go ahead and do that. First, let's add our reviewer agent. It will print reviewer start, and the system prompt for this, it will be your high standards code reviewer, review the code provided by developer and assign a quality score of 0 to 1000. Assess the structure, code quality and documentation of the code, inspect if accepted design patterns are used. We're going to follow the similar pattern of separating human, AI, and system messages, separating the system message for the reviewer agent. And finally, we'll invoke the LLM with messages and return messages. Now let's just add the node here under developer. Okay, so now we've added the node, and now we need to change our edges. So from developer, it should go to reviewer. So let's come here and copy this. And we're going to change this to developer and this to reviewer. And this from reviewer to summary. So yeah, we just added a reviewer node. It should go from init to developer, developer to reviewer, reviewer to summary, summary to end. Okay, the rest of the application should remain the same. And at this point, we can just rerun the graph and see how it's changing. Write a simple hello world app in Java. And let's see our graph in action. Now the init agent initialized the graph. Then the developer agent started. And here's the code. It created a class hello world app with a single public static method main which will do system out println hello world. Here are some instructions. So it's pretty good. And this is the developer and agent. It's a pretty simple class. Right after that, the reviewer agent kicks in, and now it's doing code review of the code that was provided. Remember, the code that's being reviewed is stored in the messages, and that's where it's getting it from. Okay, so the code reviewer is analyzing the code structure, the naming convention, code quality, overall score, is assigned a score 950 on a scale of 1000. So it's excellently serves, and that's the code reviewer. Finally, the summary agent kicks in and just prints out the state. All in all, it's again a pretty simple graph with two main nodes, developer and the reviewer. And now what we'd like to do here is add a little bit more logic. If the code reviewer's quality score is below a certain threshold, we'd like the graph to redirect back to developer so that the node can rewrite the code and send it to the code reviewer. We'd like to add a conditional logic to our graph execution whereby certain nodes can execute based on a condition. Code reviewer agent will check the quality of the code generated, and if it does not meet the criteria, which will be defined by a threshold score, it will be sent back to the developer, and this will iterate a number of times. In our case, we're going to use a threshold of 850, and we're going to execute the loop 3 times. So for 3 times, the code reviewer agent will send the code back, execution back to the developer, and the developer will rewrite the code. At the end of the 3rd iteration, the code quality score is still below the threshold, then we'll end the graph. So let's add that logic. For this, we're going to use structured output, and we're going to use LLM from structured output. We're also going to use Pydantic classes. So let's change our application by adding this logic as well as the conditional edges to our graph. We're going to start by importing certain classes from Pydantic. Those are going to be base model and field. And from typing, we're going to import literal. We're going to add 2 constants. One will be for the number of iterations. So we're going to call this number iterations. And we're going to set this to 2. And the next one will be for the quality threshold. Let's define 2 Pydantic models that we will use for the structured output for our LLMs. The first Pydantic model will represent our developer output, and we're going to call that generate code. And the second one will represent the code reviewer output, and we're going to call that quality score. Here we're going to define the Pydantic model generate code with 2 parameters. Code will hold the generated code, and number of words, we're just going to use this field to hold the number of tokens in the generated code. The second Pydantic model we're going to create will be called quality score, and the code reviewer will use this to output a score which will be an integer between 0 and 1000, and the code review comments which will be a string. So these are the 2 Pydantic models to get structured LLM output from our agents. We also would like to change our graph state to hold quality and the number of iterations between agents. We're just going to add the quality as an integer as well as the number of iterations that the code reviewer has requested reviews. Let's define our structured LLM. And for this, we're going to create 2 variables. The first one we're going to call developer structured LLM, and we're going to use this method with structured output. In this case, we're going to use the same Azure LLM dot with structured output, and we're going to pass the Pydantic model, and the method here will be JSON mode. In effect, once we start using this structured LLM, it will produce this Pydantic model. Let's do the same for our quality score. So the reviewer structured LLM, it will use a similar LLM dot with structured output, but this time we're going to pass the quality score Pydantic model. Okay, so with these 2 defined, now let's go ahead and modify our agents to start using these structured LLMs instead of our plain Azure OpenAI LLM. First, we're going to go into the developer, and here's the invocation, and here we're going to make some changes. But before that, we also need to change the system prompt. We're going to ask for it to respond in JSON with the code key containing the generated code and num words containing the count of words. So that's the first change to our system prompt. Next, we're going to change the invocation, how we invoke the LLM, and we're going to change what we print. So instead of message.content, we're going to use message.code now. And then returning, instead of message.content, again, we're going to return message.code and the number of iterations in our state. As you can see here, we're printing message.code. And what we're returning is message.code in the messages. So we only want to return the code as a message. But then we're also setting the iterations variable inside our state to the state variable +1. So we're just incrementing iterations here by 1. This is important because later on we'll check the number of iterations to determine when to pass the control back to the developer node. Okay, that's all the changes we need to make for the developer node. Now we also need to make similar changes to our reviewer node. Let's start with changing our system prompt here. And for this, we're just going to, again, instruct the agent to respond with JSON. And in this case, with the score and the comment keys in the JSON. So that's one change. Secondly, we're going to change the invocation of the LLM. So instead of this LLM, we're going to use the new LLM that we created, this variable, and we're going to change that. And here, instead of .content, we're just going to print the review and the score as defined in our Pydantic model. So let's go ahead and delete these. And here, we're going to call the reviewer structure LLM.invoke. And we're going to create two variables, one for the score, which will be the returned message.score, the other one for the comment, which will be the message.comment. We're going to print both of them. And here we're going to add a little bit of logic. And basically, if the score is less than quality threshold, we're going to change the comment and say the code quality is not up to the mark. Please rewrite the code according to my review comments and add this, return this as a comment. Okay? So that the developer node in the next iteration knows what to do with this instruction. That's all we need to do in our reviewer. Now let's add a conditional edge to our reviewer node. This will add a conditional edge by using add conditional edge to our reviewer node and with the method called QualityGateCondition. We're going to write this method next. Next change we need to make is remove this edge from reviewer to summary, because our conditional edge will determine the next node. The reviewer may choose, based on the output of this quality gate, to send the execution logic to summary or back to developer. So we need to remove this edge. Now, let's write our method. So this will be a method to determine, based on the number of iterations and the quality threshold, whether to return the execution logic back to developer or to summary. And here in the add conditional edges method, our reviewer node will use this to determine as the output whether to send it to developer or summary. And by the way, it goes to developer and then it checks for the number of iterations. So we'll see how many iterations this has been passed. And based on that, this constant we've defined up here, currently we set 2, but since it starts from 0, it's actually 3 times execution. And then it will look at the quality score, and if the quality threshold is not met, it will send the execution flow to developer, and if the quality gate is met, it will send it to summary. But if number of iterations is equal to the constant defined, then it will go straight to summary. That means we've tried a number of times to improve the code and no more improvement is possible. This is our conditional edge. And keep in mind that these methods can be quite flexible, and by utilizing state variables here, as you can see, the conditional edges receive the state as a parameter. And that's why we're keeping these number of iterations and the quality score in the state so that we can access it or modify it as needed. You can create quite a bit of sophistication in these conditional methods and pass them as conditional edges to your nodes. With our conditional edge ready, let's execute our app one more time and see it in action. Create a calculator with 4 operations. I didn't specify language. I didn't specify whether it's a function or a class. I'll let the agents determine that. So the developer started and it chose Python and created a code with add, subtract, multiply, divide, and a main function for the user input. Now the reviewer kicked in and assigned it quality score of 650 on a scale of 1,000. And here are the comments for improvement: error handling, code duplication, documentation, and so on and so forth. The developer agent took the feedback and rewrote the code, adding these comments to each function. And now the quality score improved to 750. And the comment here is the revised code shows significant improvements in structure, error handling, and documentation. So this went back and forth and no more improvement was made. So the graph ended here. And this is the summary agent, which summarized the final quality score as 750. Good example of how agents can talk to each other by using conditional edges as well as values stored in the state object. Let's give it another example. Write a mortgage interest calculation function in TypeScript. We're going to get the developer start writing the code. As a reminder, I'm using OpenAI here. And let's see our function. Calculate mortgage with principal as a number, annual interest rate, loan term in years. And here we have some comments in the code and we have some example usage. So that's really good. And the quality score, the initial quality score came in as 850. And here are some comments, especially there is no error handling to manage potential runtime errors such as division by 0. So now this review was passed to the developer agent, and the developer agent took that and added some checks. As you can see, there is a loan interest rate. So these are the edge conditions added to the code. So that's really, really good. And there's example usage. And now the quality score improved to 850 again. So that's amazing considering that two agents can have conversations based on input from one agent that is passed to the other. Here we executed it 3 times, and at the end the summary agent printed our final review, and our final score here was 850, and the number of iterations was 2. Now let's go ahead and change the number of iterations to see if this will improve the output. Go back to the code and find the number of iterations and make this 5. And let's increase our quality threshold to 950 so we have a higher standard of expectation. We're going to go back to our terminal, clear, and execute our graph with these new parameters. And let's give it another example here. Create a React component to calculate the mass of the Earth. This time we ask the graph to run 5 times. So this is iteration 1, and let's see what our agent came up with. Import React, use state. So there's some constants, and there is the calculation of the Earth. And the reviewer started here with an initial score of 400, so quite low. Has several issues that affect quality score. The component's functionality is misleading, and so on and so forth. So really good code review comments here. Then the developer is rewriting this based on the comments, and boom, the quality score improved to 850, but there's still more comments to come. Now the developer is rewriting it one more time, and now the quality score is still 850. Back to developer is trying to improve, and now with this change, the quality score went to 950, and it says the final version of the Earth display component is excellent in terms of code quality, structure. The code is clean, well organized, and finally our graph ends with our summary node. So total of 5 iterations improved the quality score to 950. Okay folks, that concludes the test of this quick class. All of the source code will be available in our GitHub repo. Feel free to check it out, run it on your own, and if you have any questions, hit me up on X by following AI Software Developer 9. Okay folks, that's a wrap. I hope this was a good investment of your time and you learned something new. If you like this content, you're going to enjoy the content about building a multi-agent network with LangGraph. Thank you for watching.